We finished last lecture yesterday talking about stresses, and one of them was bulk stress, and we said that that was pressure, in that it exerts a perpendicular force to any surface in contact with it. This is the force that water exerts on you when you're submerged. The molecules in the water are actually much more active than you can see, and they're colliding with your body many times per second. Pressure is force per area, and that per area part matters a lot. So force, our pressure is a regular P. Density, what we just talked about, is this more cursive rho, so they differ. Pressure is force per area. Per area part mattering a lot, because it's the reason that you can penetrate your skin easily with a needle, but if you apply the same force with a watermelon against your skin, it won't go through. The force is the same in each case, but it's spread out over a larger area with the watermelon than with the needle. Make sure you note the difference between pressure and force, and also density and pressure. Another difference between pressure and force is that pressure is a scalar, whereas force is of course a vector. If we have a container of fluid and we use a piston at the top surface to push down on the surface and compress the fluid, the pressure at any depth also increases by the same amount. This is called Pascal's law. So Pascal's law is pressure applied to an enclosed fluid is transmitted undiminished to every portion of the fluid and the walls of the containing vessel. A hydraulic press, hydraulic lift, hydraulic brakes, all these mechanisms take advantage of Pascal's law. If we have a container of fluid, like the one I've drawn up here, if we're applying a force here, call that F1, then there is a corresponding reaction force here that maybe you can see, P times A1. So P being the pressure and A being the area here that it's being applied to. And that is, Pascal's law says that it's transmitted undiminished to every portion of the fluid. So the pressure is the same everywhere. The pressure here is the same. The pressure here is the same. Here, 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 and all the way over here. So the pressure against that piston that we'll call is existing here is also the same P, but now this area is different, so A2, right? And so it's providing some force, F2. So what this means is you can use this to multiply the force that you're applying. So if you apply some force F1 with a smaller area here, then you get a much bigger force here, pushing up. And we can write it out in equation form. It basically just means P1 is equal to P2. Right? This being P1, that being P2, they're the same. And so if that's the same and pressure is force per area, so F1 over A1 is equal to F2 over A2. And so that means that the force that you get, F2, that's being multiplied, it's proportional to the original force, so A2 over A1, F1. And this is the proportionality factor, the ratio of the two areas. This is a force multiplying device, and it may raise some concerns immediately. You might think, does this break some sort of conservation laws? Are we getting something for free here? How are we inputting one force and getting some multiplier? Why doesn't everything use hydraulic something or other then? Well, the displacement is the same, and so if you push the smaller area piston down all the way, you'll only lift the larger area piston a little amount, because the same amount of displacement here, right? So if you push this down this far, you've displaced this one, maybe only that much. And so if you push down this far, this one maybe only goes up this much if you had something attached, like a piston here. And that's oftentimes how this works, and that's why hydraulic things need multiple pumps, right? To pump in more and more and more. So each pump, you're only putting in a small force, and you're ending up with a huge force. So you're able to lift something little by little that you otherwise wouldn't be able to lift, but you're not getting something for free. You're having to do multiple pumps, so the total displacement is the same. Here is maybe a better drawn diagram of what I did, showing a car being lifted in like a garage. So you have something very, very heavy, and you have something light here. It pushes down the little force, and you get this ginormous force over here. The pressures are the same, the areas are different.